Our Sun in the Milky Way is considered the hypergiant, the most massive and hotter object in the universe, owing to its 10,000 degrees Fahrenheit temperature and mass 333,000 times the Earth. It's so hot, illuminating and lethal that the other planets don't dare venture close to its orbit. But you know what? Astronomers have found another hotter and more deadly object, but less massive than the Sun in the distant cosmos. The astonishing sight was named Hot Brown Dwarf as its characters lie between planets and stars. Whether it's a failed star or a substellar body, it will surely make scientists scratch their heads with its mysterious properties and many more mind-boggling secrets. If you don't want to miss out on this virtual cosmic journey, tap the subscribe button and let the mission begin. The brown dwarfs are like another stellar body swirling freely in the empty dark cosmic zone. But you know what makes it special and so intriguing that astronomers are dying to delve deeper into it? The brown dwarf has a mass less than 0.075 of the Sun, but its temperature is roughly 14,000 degrees Fahrenheit, which is way beyond the heat in a hypergiant Sun. They are neither stars nor any planets, but something strange, astonishing like the cosmic oddballs that don't fit in either category. However, brown dwarfs aren't so small and tiny. Their mass is only less than the Sun as compared to Jupiter, which weighs around 13 to 18 times more than it. The brown dwarf is a sight of fascination considering its small size, which is not enough to sustain any nuclear fission reaction of ordinary hydrogen, unlike other massive sequence stars that shine too bright and are intensely illuminated. But here's a fun fact. Despite not having the powers to undergo nuclear fissions, some dwarfs are capable enough to sustain different kinds of fusion involving a heavy form of hydrogen called deuterium. And the most massive dwarfs can even fuse lithium as well. This deuterium and lithium fission happens at the lowest possible temperature and pressure, unlike the range used in fusion in stars. It's like a dimmer, more subdued version of the nuclear reactions in stars. Now, you may have never imagined the brown dwarf wandering close to the superhot star, as they are super prone to vanishing owing to their small size. But here's an adventurous brown dwarf named WD0032-317b is just doing that. It's so close to its star that its already hot temperature keeps skyrocketing to over 8,000 Kelvin, leaving the Sun behind with 5,778 Kelvin. These dwarfs also appear in different colors depending on their temperatures. The warmer ones are possibly orange or red, but the cooler dwarfs will likely appear in magenta or black hues. Their extreme temperature is truly mind-boggling because brown dwarfs are generally cooler than stars. They once considered a lukewarm cup of water compared to the blazing heat of a star. But WD0032-317b has shattered all the stereotypes and got the crown to be the hottest brown dwarf ever to exist. The scorching heat has become an amazing opportunity for all astronomers to research its peculiar properties. However, it's not as easy to study as it seems. When it ventures close to blazing stars, its signal gets mixed with the activity with the star it's orbiting, since it becomes almost impossible for the scientists to track the signal smoothly. Hence, they have to be very clear and patient to tease out the brown dwarf's unique characteristics from the chaos of its star's activity. You may wonder how the WD0032-317b brown dwarf can generate this much temperature, but I bet you're not ready for the backstory. So let's start from the start. The giant interstellar bodies, our stars, shine bright for most of their lives until their nuclear fuel runs out. As the fusion comes to an end, the stars stop shining and go through a dramatic transition state. What was left after the remnants, called white dwarf, so dense, incredibly compact, contains peculiar properties and crammed a significant part of the star's mass. In addition to its small size, the white dwarf radiates heat and light, a final glowing testament to their former brilliance. When you enter the binary system, you'll find two celestial bodies locked in gravitational pull orbiting around the common center. This arrangement provides the scientists a new way to study those interstellar bodies. The brown dwarf orbits closely with its companion white dwarf named WD0032-317, which is blasting its hot brown surface with radiation. The brown dwarf's adjacent side to the white dwarf is said to have 11,000 degrees Fahrenheit cooler temperature. The pair opens new chapters for scientists to study exoplanets that orbit very close to hot, massive stars. The binary system of dwarf also serves as an analog for an ultra-hot Jupiter system, which is much easier to observe. When you pair white dwarf and brown dwarf, it crams into the binary system, which basically helps emit light to the dark parts of the universe where light has no existence. The dim glow of the white dwarf allows us to observe the brown dwarf more clearly, even if it's as elusive as a ghost. Studying the binary system also gives us insights into the extreme environments of the universe that are otherwise challenging to capture. It's no less than like sneaking backstage of space during a gravitational ballet of dwarves. However, it's worth noticing that revealing the white dwarf's companion was made possible with a giant ultraviolet visual Echelle spectrograph, or UVES, a much more powerful equipment for astronomers. UVES doesn't only see the light but also helps disperse into the 7 components, revealing the unique fingerprints of different elements. With this analysis, the scientists could observe that the white dwarf WD0032-317 isn't a binary system of 2 other white dwarfs, but it actually has a companion called brown dwarf, also known as WD0032-317b. The brown dwarf also shares the secrets of its orbit, the celestial choreography, with the white dwarf that was a mysterious secret until then. Hallukin, a scientist, and his team also figured out that the mass of the brown dwarf is between 75 and 88 times that of Jupiter, which is considered a hefty weight in the cosmic arena. These 2 dwarfs are astonishingly orbiting each other with short intervals of just 2.3 hours. The tidal dance, or more precisely a celestial tidal ballet, simply refers to when 2 bodies are forever linked with each other and never let go. In our binary system, the brown dwarf WD0032-317b is interlocked with its companion white dwarf. The gravitational force between both dwarfs create a cosmic leash, forcing each into a synchronized dance. When one side of the dwarf is lightened with bright light, the other side is shrouded with eternal darkness. However, in the tidal locking, scientists also noticed some extremities of temperatures. It's like the blazing afternoon heat on the mountaintop suddenly reduces to icy cold midnight. WD0032-317b experienced this roller coaster throughout their motion. On the day side, when the brown dwarf faces the scorching heat of its stars, the temperature can even be soared to mind-boggling heights that could be a blistering 9,800 Kelvin. This stellar body epitomizes how strange the universe behaves and how precisely it is stretched. Scientists say the heat is so intense that it can even break down the atoms into their fundamental particles. On the other hand, when you turn around the night side of a brown dwarf, your mind will be filled with astonishment. It has total eternal darkness where temperature remains ice cold throughout the orbit motion of stars ranging around 1300 to 3000 Kelvin. The whole experience is like moving from a scorching Arabian desert to a cool Arctic night all of a sudden. However, the temperature between the 2 faces of brown dwarfs has a huge difference. With a rough calculation, the temperature swing is 4 times larger than we observe on exoplanets like KELT 96b, which is also said to have scorching heat ranges. This extreme variation reveals the dramatic contrast within the brown dwarf environment and tells us the story of a cosmic world undergoing both intense star radiations and the chill of its own darkness. Coming to the equilibrium temperature that the hot brown dwarf observes is also mind-boggling. After neglecting intrinsic luminosity and reflection, it ranges around 5100 Kelvin, which is incredibly hot even to imagine. This heat range doesn't only determine the intensity the brown dwarf has to go through, but it also emphasizes its role as an extreme object that challenges our imagination about the universe. The binary system doesn't only shed light on the extreme space temperatures, but it's a key to unlocking the mysteries of many other celestial partnerships. It also helps scientists reveal how intense radiations and heat of massive stars affect their more diminutive companions. The WD-0032317b is challenging our thoughts on what's possible in the universe. It acts as the bridge to connect all the interests of the scientists. So let's end the virtual voyage here. Make sure to comment below how you see a brown dwarf, an object hotter than the sun.